Hello everyone. In this video we are going to study about hardwired implementation. So hardwired implementation is one of the techniques for implementing the control unit. So control unit is one of the components of CPU. So this model of this control unit, we can see the what are the inputs and what output is coming out. So the key inputs of this control unit is the instruction register, clock, flags and control signals from the control bus. So here the instruction register, how it is used in control unit. Control unit makes use of the opcode and will perform the different actions. So as we know, in every instruction format we have the opcode field and the address field. So using the opcode field, this control unit will perform different actions for different instructions, and there should be a unique logic input for each opcode. And the clock signal, this clock portion of this control unit issues a repetitive sequence of pulses. The ones and zeros will be issued by this clock, and this is helpful in measuring the duration of the micro operations. So for executing every instruction, there are some steps, and in each step will be having the micro operations. So the how much duration each micro operation takes, it calculated by this clock. And the flags and the control bus signals, here it has some meaning for each individual bit. And the next one is the control unit logic. So the internal logic of the control unit, it produces the output control signals as a function of its input signals. So based on the input signals we give, the control unit has an internal logic which produces the output signals, and for each of these control signal, a Boolean expression has to be found or derived as a function of the inputs. Look into this picture. So there is there are some few micro operations and the control signals given in this table for a particular instruction. So that instruction goes through the fetch operation, the indirect fetch cycle, indirect cycle and the interrupt cycle, and in each cycle it has some steps. It has 3 steps, T1, T2, T3 and 4 micro operations, and for each step some active control signals were produced. So now for each of these control signals that has been produced, a Boolean function has to be derived. So we take one such control signal and see how it is happening. So for example, here in fetch cycle you can see that at time T2 there is a control signal called C5, and also in indirect cycle also at time T2 we have a control signal C5. So for this for what this control signal C5 is doing, it causes the data to be read from external bus into the memory buffer register. If you see here, so it causes the data to be read from external memory location to the memory buffer register. The same thing happening here in the indirect cycle also. So for this particular control signal, we need to derive a Boolean function or a Boolean expression. So before that, other two new control signals were defined, P and Q, which have the following interpretation. For fetch cycle, it is given as 0, 0. For indirect cycle, it is 0, 1. For execute cycle, 1, 0, and interrupt cycle, it is 1, 1. So now for this particular control signal C5, the Boolean expression can be defined as, you can see here both these control signal, this control signal C5, it appears in both the cycles, fetch and the indirect cycle at time T2. And you can see here for fetch cycle it is given as 0, 0. So we negate it to make it as 1, or we are initiating it. So P bar Q bar into T2 plus here for indirect cycle it is 0, 1. So P bar into Q into T2. So now a Boolean expression is defined for this control signal C5. So similarly, for every this process has to be repeated for every control signal generated by the processor. So as a result, we will be ending up with a set of Boolean equations that define the behavior of the control unit and hence of the processor. So this is how this hardwired implementation will be helpful in implementing the control unit. Thank you.